to take a look at number 2 from your lime green packet. Okay, you should have this. Your homework was 1 and 4. And now we're going to look at 2 and 3. So on number 2, the first step I need to do is factor. Factor, factor, factor. Now you might be a little confused because this is a cubic equation. But notice in my numerator, I have an x cubed minus 25x. So I can actually factor out an x from my numerator so that I have x squared minus 25. This is convenient because I have a difference of 2 squares, which will factor into 2 binomials. I'm going to keep factoring, and I get x times x minus 5, x plus 5. My numerator can factor down into these 3 linear factors, x times x minus 5 times x plus 5. My denominator can also be factored. It is a quadratic that I can break down into 2 linear terms. X squared is x times x. Then I have to think, what 2 numbers will multiply to get a negative 15, but add to get a positive 2? Well, one is going to be positive and one is going to be a negative number. I know 5 and 3 multiply to get 15 and have a difference of 2. Since 5 is the larger number, it takes the middle sign. So I'm going to have x plus 5, x minus 3. If you're not sure, distribute this back out, or FOIL, and you should get what we started with, x squared plus 2x minus 15. So in factored form, this is what my polynomial function looks like. Now notice, I have a factor in my numerator and my denominator that's the same, x plus 5. This will cancel. But when I cancel that x plus 5, an alarm should go off in my head that there's still a hole at the value that makes this 0. So down here where it says hole, I'm going to have a hole at the value x equals negative 5. Because negative 5 would make this factor equal to 0. So I still have a hole at x equals negative 5. Keep that in mind. Now let's go back and find all of these points. The y-intercept. The y-intercept, you're going to cover up the x values. I'm going to plug 0 in. F of 0 is going to leave me with 0 in my numerator, negative 15 in my denominator, which means my y-intercept is at 0, 0. I've got an intercept right here. My x-intercept, we set our numerator equal to 0. Well, I can use the factored form of my numerator. I can use this factored form of my numerator. So x-intercept, set your numerator equal to 0. So I have x times x minus 5 equals 0. So either x equals 0, well I already knew that was an intercept, that's the origin. I already have that on my graph. Or x minus 5 equals 0, which means x equals 5 is an intercept. So I can also graph this intercept. 1, 2, 3, 4, 5. And there are my intercepts. Vertical asymptote is where your denominator equals 0, where your denominator equals 0. Again, I can use my factored form here. This is going to be x minus 3 equals 0. I already accounted for this x plus 5. X equals negative 5, I have a hole. But I'm going to have an asymptote at x equals 3. So I'm going to go ahead and put that on my graph. 1, 2, 3. Vertical asymptote at x equals 3. Horizontal asymptote. The degree of my numerator is 3. The degree of my denominator is 2. Look at this original problem. the degree of my numerator is greater than my degree of my denominator, so I don't have a horizontal asymptote. I have a slant or oblique asymptote, because the difference is exactly 1. This is 1 greater. So how do I find that? Well, I have to do division. You have 2 options. You could divide using this original function, but then you'd have to do long division. Or you could divide using the simplified, where we'd already crossed out x plus 5. I'm going to choose to divide this way so I can use synthetic division. Notice, if I redistribute this x, I'm going to get my function equals x squared minus 5x. All I did was redistribute this x into x minus 5 all over x minus 3. This is the same function, it's only simplified because I crossed out my like factors. Now I can do synthetic division. I have a 3 outside, and then I list my coefficients. 1x squared, negative 5x, a 0 for my constant. Synthetic division, you bring down your leading coefficient. You multiply and add 1 times 3. Add these up, negative 2. Negative 2 times 6. Add these up, my remainder is negative 6. My remainder doesn't matter. So my oblique asymptote, or my slant asymptote, they mean the same thing, is going to be at the line y equals 1x minus 2. 1x minus 2. So let me graph that on my line. That is a straight line with a slope of 1, a y-intercept of negative 2. Right, like that. So this green and the red line are my guides for my graph, the overall guides for my graph. Now I could pick more points and figure out what different values are going to be. And you might want to create a table, but the more you do, you'll start to see that this red line guides my graph. So my graph has to go up towards this line and go down towards this green line. And then it's the opposite. It's going to go up towards the green line over here and down towards the red line over here. It's a rough sketch of what your graph looks like. Okay, I could pick out more points and be more precise. We're going to skip part F for right now. We're going to skip over that. That's not going to be tested. It's not the focus.